So hello and welcome to the last lecture of this database systems course, the session 5. So today this will be about the NoSQL systems. So the first question is, what does NoSQL mean? Although it seems that NoSQL meaning no SQL, it is actually not NoSQL, but it means not only SQL. So people who have joined in, so this is pretty much the first slide. So you're not late. We've been waiting, and I'm hoping everybody is safe. So let me restart. So NoSQL is not NoSQL, but it actually means not only SQL. So it will have SQL plus some other things. So it aims to provide the following properties: scalability, flexibility, naturalness, distribution, and performance. So scalability, so the scalability essentially means that more and more data can be added without much of a problem in the system. So let me clarify what does that mean. So let's consider a very large system, for example, Facebook and all those things, right? So if Facebook adds 1 million more users today, it should not need to redeploy everything. It should just work. So that is called scalability. So you can just add in more data and that still works. Okay. And we'll kind of see, which we will kind of compare it against the relational database, the SQL systems. So the relational databases, although are scalable to some extent, but it cannot go beyond one machine. So if whatever fits into one machine, it can keep on adding. But if the data grows beyond what can fit into a machine, then it is in, then it has got some trouble. Okay. And for many applications nowadays, for example, the Facebook data and all those things, the data really cannot fit into one machine, no matter how much big the machine is. It is just humongous. So Facebook, Google, and all of these things. Okay. So that's why scalability is a very, very important property. And actually NoSQL came up with this very, I mean, the big game was to achieve this scalability. Of course, it has its other aims, the 4 other aims. So the second one, sorry, is the flexibility. Now, what do you mean by flexibility is that in an SQL system or a relational database system, as we saw that the relations, the schema has to be defined very well before you do anything else. So it has to be exactly said that there is a table called these are the attributes, this is what the attribute mean, the domain of it, and all of these things. So it's not flexible in the sense that if you want to change it after a database has been deployed and it's running, it's very hard actually, because you'll probably stop all the querying, probably rehash all the data and do a lot of work. So it's not so flexible. However, NoSQL systems aim to, want to get to that flexibility. Okay. Then the third thing is called naturalness. So by naturalness, it's kind of related to the flexibility. For example, let's again consider this Facebook graph, right? So the Facebook graph, so there are people, there are posts, there are pages, there are likes, there are different kinds of emojis, and there are different kinds of comments, all those things. So if you want to model all of that in a relational database system, there has to be saying, okay, there is a table called people, there is a table called like, and all of these things, right? Rather, a more natural way of modeling that entire Facebook graph is to actually say that, look, this is a graph, right? So each node is either a person or a post or a page, etc. And whenever somebody becomes a friend, you just add an age, you just add a relationship, and you mark that relationship with whether it's a like post, whether it's a love post, whether it's a hate post, whatever. So that's much more natural to think of and much more natural to model. Okay. All right. Then the fourth one is called distribution, and this is essentially that the first point that we were talking about. So the distributed nature of the database. So in relational databases, the data is pretty much just stuck into one machine. You can make the machine very big, but it's stuck into one machine. So you cannot really distribute it very well. However, as we argued, that some data is so big that you cannot have any machine that can hold all the data. So you want to distribute it across different things, and that's why it is thing. And the final one is performance. And this performance, by performance, I do mean the actual runtime performance, the efficiency, the running time efficiency. So if you have a post, if you actually post something, then it has to be up in your friend's page quickly in real time, so that the friend can like and you can see and all those things. It cannot be that it will take a day or an hour to get posted. So that's what performance is about. Okay. So the contrast with the RDBMS or the SQL database is that the SQL databases want to provide this very famous properties called ACID properties. So the ACID is an acronym because of these four things: atomicity, consistency, isolation, and durability. So let's go a little bit over this. It's important to kind of contrast these two things. So the DBMS, so the relational database, the atomicity is saying that either all operations of a transaction are reflected or none are reflected. And the quintessential example here is that suppose money is being transferred from account of A to account of B, then there are two operations that are actually happening, right? That A's account is debited and B's account is credited. So two operations. Now, the atomicity says that, okay, either both the debit and the credit happens or none of them happen. So it should not be that the debit has happened, but the credit has not happened, or the credit has happened that the debit has not happened, right? Then there is a problem. That's what called atomicity. Consistency is that, right? I mean, so if there's a, if the database was consistent before this transaction, then it must be consistent after it. So essentially, the SQL databases or the relational databases work in this form of what is called in transactions. So every kind of operation that changes data is called a transaction. So so this money transfer is one transaction and so on. So the consistency says that, look, if things were okay before it, it should be okay after it as well. Okay. The third property is isolation. So although multiple transactions may execute concurrently, each transaction must be unaware of the others. So what does that mean? Is that suppose A is transferring money to B and C is transferring money to D, or maybe even B is transferring money to C, right? So for the first transaction, it should not matter whether the second transaction is happening or not happening, whether it has passed, failed, rather. It is as if this is in isolation, right? As if it's unaware of others. It doesn't matter whether there things are happening. That's isolation. And the fourth property is called durability. And so the durability is essentially saying that if a transaction finishes successfully, if it is declared by the database engine that a transaction has finished successfully, the changes must be made permanent. So if you say that the transfer has gone through, then no matter what happens to the bank or the computer or whatever, the next time you look at the account balances, that must be reflected the correct manner. So that is called durability. So it's durable. It has to be there. Okay. So this NoSQL paradigm, it originated as an anti-SQL thing. It's actually saying, well, no, we do not require SQL. SQL is bad. But later on, it changed because there are certain properties of this RDBMS is good, and you cannot always ignore it. So this new paradigm kind of came up, which is called new SQL. I'm sorry, which is called new SQL, which is essentially saying, look, we will try to get the properties of this scalability, flexibility, all those things. And we will also try to get some properties of the SQL databases, maybe atomicity, maybe consistency, whatever, something like that. So it's kind of a mix of both the things. That is what this term called the new SQL. So that's the new paradigm. And this NoSQL, new SQL, these are the terms that, that one should be aware of. Okay. In this, there is a very famous theorem called the CAP theorem. So it's essentially CAP theorem. So CAP are the three properties. The first property, C, is for consistency. And we saw what consistency means. The A means availability. Now, availability means that whether when I want to access the database, whether I can do it or not. So for example, Facebook is always available, right? Whenever you want to post, it is available. Okay. The third property is called partition tolerance, which means that let's say so partition tolerance meaning the distributed property. So if I partition the data, so if I add in one more machine, can I partition the data into this two machines such that I have better scalability, I have better performance and all those things? So can this be done? Right? So let's see. So the theorem says that these three properties together cannot be satisfied. So you can satisfy at most two of them at a time. So there cannot be a system where all these three properties are satisfied. So what does it mean? So CA, so there is this RDBMSs, the standard SQL systems are this, they are consistent, of course, and they are available because they can always be up and all those things. Right? But however, they are not partition tolerant because you just cannot add in another machine and the data does not move or does not model itself very nicely across. Then the second one is called CP, the consistency and partition tolerance. So this is what is available is consistent. So if something is available, if some data is, you can access it, then it is consistent. So for example, MongoDB and all those things. However, there may be some parts of the data that are not available, that you cannot just, you are not aware that, I mean, that is there, or if you query, nothing will be returned, okay? Then the third thing is something like Cassandra, this AP, it is available and partition tolerant. However, it may not be consistent. So what does that mean? For example, Cassandra essentially, say it maintains copies of the data, correct? So one of the copies will be always available for querying or whatever. And it is, I mean, if you add more machines, it naturally flows and all those things. However, the problem is the data may not be consistent. So because as you see, if there are multiple copies, the copies may not be reflecting the correct version. So if you change the value of one of the copies, that change has to flow to the other copies, and it's not immediate. It may not be consistent. So it may be showing you an old value and things like that. So it is not consistent. Okay. Just as a point, although it is called a theorem, it is actually a hypothesis because there is no concrete proof of this. There is, I mean, the proof is kind of a negative proof saying that, look, there is no such system currently known which can support all three of them. But that does not mean there cannot be any system. So it's basically a hypothesis, but it's more famous as a theorem. Okay. Now, because this RDBMS has these ACID properties, the NoSQL systems has what is called the base properties. And base and acid, if you remember high school chemistry, it's essentially opposite of each other. So this has to be the opposite of acid properties. So base properties, the first one is basically available. So it is available. Yeah, mostly you can get the data whenever you want. Then it is soft state, meaning the data may change without any input to maintain consistency. And I have to go back to the example of Cassandra. Well, if you write to one of the copies, the other copies are not guaranteed to be consistent right at that moment. So suppose you have written to copy 1, and now before this copy 1's data has flown to copy 2, you read it. So you read an old value of copy 2, and after a while you again read copy 2. By this time it has changed because that flow has changed, because that update from copy 1 has come to this copy 2. But copy 1 and copy 2 are different machines, right? So it seems while you are sitting on this copy 2 machine, it seems that, well, I have not done anything. I've just read the data maybe now and after 5 minutes, and suddenly it has changed. So that's why it is called a soft state. Okay. The third property is called eventual consistency. So eventually things will be consistent, because finally all the copies, if you do not perturb it any further, if you do not keep on writing, etc., finally all the data will be the same. So finally it will be consistent. Okay. So it essentially sacrifices the strong consistency requirement, the immediate consistency. So the RDBMS are immediate consistency. So if you write a data, it has to be correct before you can query it and all those. So that is not there here. Okay. So this is to counter acid, as we said. Okay. So so there are essentially, I mean, so there are 4 main types of NoSQL data stores. The first one is columnar families. And so it's column oriented. RDBMS, for example, MonadDB, etc. So it's actually an RDBMS. The important point to note is that this is actually an RDBMS. Then the second is big table data system. So these are, again, the second thing are, these are like tables, but it's not so rigidly typed in. The schemas are not so rigidly typed in, but these are like tables. So HBase and all those things are there. Then the third one is document databases. So the document databases are just key value kind of thing. So there is a key for every piece of data, and then the rest of the data, the details of the data is just called a value. And MongoDB is one big example of it. Finally, there are graph databases. And so Neo4j is the original one for Facebook. So graph databases, the graph data structure in computer science is used like, so every page is a node. There is a relationship with another node, maybe a relationship with a page, maybe a relationship with a post, and so on and so forth. That's called a graph database. Okay. So these are the 4 types of business. So on NoSQL, although it has started as anti-SQL, it is not really anti-SQL. It's no more an anti-SQL. It is more of a realization that some cases RDBMS does not scale or distribute, so or acidity is an overkill. By acidity is an overkill, what I mean is that, the strong consistency is not always required. For example, in a Facebook post, if you post now and your friend sees it after 1 minute, it's still okay. It does not have to be exactly that thing. Or if you post before your third friend and your second friend sees the third friend's post earlier than you, well, you may not be very happy, but it's not a big deal. It's not such a big deal. The world will not fall apart. Okay, so not such a thing. Okay, so however, please, it has to be remembered that NoSQL is not good for every scenario. Okay, there are places where strong consistency cannot be sacrificed. For example, bank transactions. You really cannot sacrifice bank transactions. You cannot really sacrifice the consistency requirements of bank transactions. That will be disaster. Okay. So most legacy systems still use RDBMS, and many of these NoSQL systems are increasingly using the features of RDBMS. So that's what. So although it started with NoSQL, started as NoSQL, it is no longer just NoSQL. It is using more and more of these RDBMS properties. So it is becoming like what is called the new SQL. And the trend and the horizon is shifting very rapidly. Almost every day, some new NoSQL database is coming up, and all those things. So one of the big important things, one of the big important trends is this cloud computing and big data, what was called the big data. So if there are no questions, if there are any questions, please do ask. Otherwise, I'll move on to the second part of today's discussion, which is on big data. All right, so let's move on to, okay, great. So let's move on to big data. What is big data? So we know this is a term that is floating around. It is quite a famous term, and it seems to be useful, etc. But what on earth is big data? What does big data mean? So big data essentially means data which is big. Now the question is, well, big is fine, but how big is big? What does big mean? So for sociologists, maybe 10 subjects is big, because they have to collect data, they have to go to their homes, ask it lots of questions and all those things. For social networks, terabytes is normal, Facebook, etc. For astrophysicists, terabytes is an hour's worth, so they actually collect petabytes of data. So for them, if you say terabytes, they say, oh, that's not so much big. Well, maybe petabytes is big. So it depends on the, so there is no absolute definition of threshold. It depends on the what do you call, the domain that is happening. So when data, so the standard operating definition is that when the data is bigger than most standard machines can store or most algorithms can handle, then it is called big data. Okay. So having large volumes of data requires, see, because originally before this big data paradigm kicked on, if you had large volumes of data, it will require new techniques, new tools, new architectures to handle them, right? So that is what this big data has essentially done. So it allows you solving newer problems. Of course, it can also solve some of the older problems in a better manner, but it also allows you solving some newer problems. So Facebook graphs, social networking graphs, these are actually examples of big data, right? You could not think of analyzing the entire Facebook data before this big data paradigm kicked in. I mean, there's just no way one could have done that, but now you can, okay? So there are three important properties of big data that are very, very important. So the properties are volume, variety, and velocity. So what does volume mean? Volume essentially means just the size of data, right? So when the data is extremely large in size, how do we load it? How to even index it, query it, etc. That's called the volume problem of the big data, right? Because please understand this. So if the memory, the RAM in your machine is, let's say, 64 gigabytes, and the hard drive in your machine is 1 terabytes, and the data is 1 petabytes, how do you even load it? How do you even store it? So that's the volume problem, right? Then the second property or the issue is of variety. So the data can be semi-structured, unstructured. It's not clear. It may not be always in this very nice format of SQL and all those things. So it may be like text, which is semi-structured, or it may be completely unstructured in any format and all those things. So how to do that? The third one is velocity. Velocity is that the data can arrive at real time and can be streaming. So Facebook, it probably gets a billion posts every minute, right? A billion activities, may not be posts. So the velocity, so the speed at which the data is coming is phenomenal. You probably cannot store or process or do whatever unless you have these big data solutions, etc. So that's the things. Now, although there were these 3 V's, there are these many other V's, the 7 V's actually it's now called. So this veracity, validity, visibility, variability, all of this is also part of the big data V's now. So veracity is whether the data is correct. Validity is the data valid up to this point in time or it has expired. Visibility is, can I actually see that the data, what is happening to the data, etc. And the variability is that does the data change by itself or there's something is happening. So how variable the data is. Okay. So enablers of big data, of course, why did this big data paradigm kicked in? Because now we have improved storage and type, we have improved processing power, we have improved data collection mechanisms, we have improved network speed, and we have improved computer architecture systems, right? So, and all of these were needed before we can start solving these big data problems. And fortunately, we are in that phase of the computer science where these things are available now, and so we can solve more and more of these big data problems. And of course, one of probably the more important thing is increased capital and increased business, right? So because companies are seeing much more value in investing in big data research, and I'm sure everywhere in the world, people want to do this artificial intelligence and big data research because they can see some value, because they can actually get some revenue out of this. So they are willing to put in more capital because there is more business in it. And that also helps a lot and actually a big enabler of this big data paradigm. Okay. So there are different tools for big data. So this the hosting tools, Amazon EC2. So we may or may not have heard about this Amazon EC2. This is a distributed server or cloud. So essentially it means that you need not buy machines and configure them and install them in your thing. You can just rent the cloud or rent computing power from Amazon. This is called hosting. Then the HDFS, age-based things, they have a scalable file system. So the file system, if you just put in more files, it will automatically scale, and it does not, the end user does not require to worry much, right? Then the programming model, the Hadoop programming model, the distributed scalable processing, the MapReduce framework, essentially that big thing. And the database part of it is the NoSQL or the NoSQL databases, so age-based, MongoDB, Cassandra, all those things. And the operations, different operations that you can do are querying, indexing, analytics, so data mining, information retrieval. And then there is a tool called Mahout, which can be worked on the top of Hadoop. This is a machine learning tool. Okay. So coming from all of this big data, there is another new term which is called data science. Well, it's not so new term. Yeah, I mean, it has been around for some time now. So data science is not such a new term, and it's essentially given a large amount of data or some amount of data. We want to find some trends, some patterns. We want to do some new things that could not have been done. Big data, NoSQL systems, etc., are a big help in trying to do that. Okay. So doing big data, I mean, contrary to the belief, it may not always require a large software investment, because as I said, there are many open source tools, and there are many like this distributed cloud, etc., which can be rented. So it's not require a very large investment. It may start. You have a decent amount of hardware and software and capital, and one can start working on big data and all those things, right? So cloud, etc., can be rented, and many applications still do not require big data. Okay, so many applications still do not require big data. Okay, so we will talk about one particular thing, which is the MongoDB. But before that, are there any questions? And I will just come for a second. I'll just need to plug in my charger. Okay, this laptop is dying, so please just allow me one more minute. Hello. Sorry for the delay. So I'm back. So are there any more questions? Otherwise, what we will do is just like we did this SQLite thing. We saw a demo, etc. We will go to this MongoDB. We'll spend a little bit time with MongoDB, and that's a standard. I mean, that's one of these NoSQL databases, a very popular one, probably the most popular one. So we will just see how to work with it. Okay, all right. So MongoDB. Is a key value store based database. Okay. Now, what does it mean to see it's a key value store based database? So all the data, it is so corresponding to, so whenever we say there is a table or relation in RDBMS, the corresponding term in MongoDB is called a collection. Okay. Now, collection is essentially so a database consists of multiple collections, and each collection are composed of documents. So the documents are same as what the tuples were in a relation, right? So remember, it's as in a relation, it's a table, and each row was a tuple, right? So each row essentially is about one particular entity, correct? So here, each document is about one particular entity. So although it's called a document, please don't think that it is always a typed text document. It's just called a document. It is a technical term that is used in MongoDB. It can be about any data. It need not be just text, right? It's just called a document. Okay. And now, just like in a tuple, there were attributes. So here also in a document, there are fields. Now, the important part is that each field is something called a key value pair. So the key denotes the name of the field, and the value denotes the value actually. Now, so this is one very big difference with the SQL database. Remember, in SQL, the key, the name of the field is all predefined. That's coming from the schema of it. So that cannot be changed. and the value is just the value, because you know which key or which attribute it comes from. The value can be always linked to that attribute. So because if it is under this column name, I know that I'm talking about this name, right? However, here it's a free format, it's a flexible format. There is no schema. There is no schema for a document. So you can add in whatever one wants. So you can add in anything that you want. So for example, for a student, you may say roll colon 1 2 3 4 5. So this is essentially a JSON format. Now what does this mean? This roll colon 1 2 3 4 5. The roll means that this is the name of the field. This is the key. And the value of that role field is 1 2 3 4 5. Remember, the next document may not have a role field or may have any field. It's not necessary that it has always got role. But so here, every attribute, every field that is there in a document has to have a key and a value. This is why it's called the key value pair. Okay. Now, corresponding to this tuple, there is also a concept of a primary key, but the primary key is always this underscore ID. This is underscore ID. It is always the underscore ID field. Okay, there is no change to it. It is always the underscore ID field. And this is assigned by the MongoDB server itself. So for example, look at this. This is one document. So you see this one curly brace to another curly brace is one document. Okay. And in this document, because it's a document, it has to have this underscore ID field, which is some object ID which is assigned by the MongoDB. It has then got this field called role, whose value is 1 1 2 3 4. Please also remember that whenever it's in quotes, that means it's a string. So every name, every key is a name of a field, right? So it has to be under quotes, and because it's a string. And this value is 1 1 2 3 4. So 1 1 2 3 4 is actually an integer, because the roll number is an actual integer. Then it has also another field called name, and which the name happens to be whatever, Sita Janaki something. Then it also happens to have another field which is called department, whose value is 18. And this is the format in which the MongoDB documents look like. So each document, so the collection of these documents form this collection, which is called a collection, and each document looks like this. So underscore ID is one field, role is a field, name is another field, and department is another field. So there are 4 fields here, right? Although while inserting or while specifying, there will be only 3 fields specified. This underscore ID will be assigned by the MongoDB server itself. Okay. All right. So how does one create and this thing? So let's say once a document is inserted, a collection is created automatically. So if you say, so it's schemaless. So if you say DB, now you see, please note this notation, this DB, it's a keyword. That's why it's in capital. Insert one is in keyword. Sorry, that's why it's in bold letters. Okay. And this department is the name of the collection. So if I am inserting a document in this collection, the collection, if it is not created already, it is automatically created. Now, so at the end of this, what is happening is that I have inserted a document into this collection called department. Now, what is that document? I am inserting, please understand, I am inserting a document where I am saying, look, I want the department value to be 12, the name value to be the string AE. I am not specifying the underscore ID. That will be assigned by the MongoDB. Okay. And similarly, one can insert multiple things. Just note the syntax a little bit, because it's multiple. It's an array kind of thing. It's a this bracket, third bracket. I mean the square brackets, that thing, and you can insert multiple things. And you are saying insert name. Okay. All right. So what are the documents in a collection can be listed by this find command. So if you say after this insertion, if you now say, well, db.department.find, right? Then it will actually list these 3 things. Look, it has inserted this underscore ID field by itself, and then it is the field that was inserted. So 12 AE, 14 echo, 18 CAC, and so on. Right? So there is no problem. Okay, let's go in. So, but sometimes, suppose what may happen is that you have lots of data in a file. You do not want to enter it one by one, right? So there is a command called Mongo import, which can insert all the files, I mean, all the data from a file, and we'll see some examples of it. So and for that, this db student dot find, I mean, then once you have inserted, and if you do, it will just list out all of it. Now, just the find command here, just the find command actually just lists everything that is in the document. I mean, that is in the collection. I'm very sorry. So all the documents that are in the collection. But suppose you want to find only some documents and not all of them, then essentially using something called a filter. Okay. So the filter is the following thing. Okay. So you see this thing. So db.student.find. Okay. And now you are saying the filter. So what the filter is saying that, look, I want the roll number field to be 11234. Okay. So it will only output those documents where the roll number field is exactly equal to 11234, right? Which is only this one document in the collection. Okay, not everything else. You can use multiple fields and you can use non-equality. So for example, you may say, please find me the things where the roll number is greater than 11234. This $GT, this stands for greater than. So you are saying, please find me all the things where the roll number is greater than 11234 and the department is 12. So this comma saying, and the department is 12. So you are finding all the students whose roll number is greater than 11234 and the department is 12. Okay, great. You can also use an OR search, which is $OR. So you can say, well, you find me all the roll numbers. So you find me the students where the roll number is greater than 11234 or the department is less than equal to 80. So you see, it is either or. I mean, it may have both, but it is generally either or. I mean, so this satisfies the first condition, this satisfies the second condition, whatever, it is a or condition. And then or can also be combined. Okay, so it's leave it to this thing. Okay. Then you may not be interested in finding, you may not be interested in listing all of this. For example, so whenever you do a find command, all the details of the documents that are found are listed. You may not be interested in that. You may be interested in listing only certain fields, right? Remember, this is the select comma select. So in the SQL query, this is the select field 1, field 2. That was what was done in select. So the corresponding thing here is the projection operation. There's a projection operation. It's coming from that relational algebra. If you go back to the slides, you can find it. And it is coming from this thing is that, so here is the what I want to find. I want to find I want to find all the documents where the roll number is greater than 11240. Great. But whenever I find it, I only want to project, or I only want to list the role and department. By this :1, essentially I'm saying, please turn on role, please turn on department. Correct. So you see in the output, the name is not listed any further. Okay. So because only the role and the department is whatever wanted to be listed. So the name is not listed any further. However, the underscore ID is still listed because that is by default. Correct. Now to stop that, you have to explicitly put a 0. So I am saying, please explicitly turn off underscore ID 0. Okay. I absolutely do not want underscore ID to be this thing. So then and only then it will be turned off. Okay. So a little bit of practice and you should be able to go well. I mean, we'll do that. So the number of tuples can be counted. Of course, if you just say count db.student.count, it will tell you that there are 5 tuples. Great. It can also be listed, distinct. So I just want to list the distinct elements of this department. I don't want everything. So it's just 12, 14, and 18. Great. It can be also sorted. By sorting, you require this aggregate command. You have to use this aggregate command, and then you say, well, sort, please sort. Sort on what? Sort on name. So the I want to use the name. I want to turn on sorting on name. So that's why this is :1. And you see this output is on the this listed on name. So HIRRS and so on. So it will be sorted. Okay. Great. And finally, remember this in SQL, there was this group by. So you want to group some of those attributes together, and I mean some of the documents together, and then run something on this, right? So how to do that? So here is how to do that. So you are saying aggregate command. So it is an aggregate because finally you want to run some aggregate on it. So group by and then. So you are saying, look, I want to do this grouping. Grouping on what? I want to say, I want to group it on department. Now this is a thing to remember. It is saying $department because when the field is department, the name of the field is $department. Okay. So I'm saying, please produce me a new group where the underscore ID, so where the underscore ID meaning it's a primary key. So that means it's where the grouping is used. I want to group it on this $department, which means I want to group it on the department. Then for each group, please fix me another, please find another, another attribute called total. And the total is the sum of all of them, correct? So it's just the sum of one, but that means it's just the sum of all of them, okay? So that means here, if you do that, then it essentially says underscore ID is 14. That means the department field is 14 and the total, so the number of, so the sum, so the number of collections in that department is 1. And when the department field is 18, it is 2. When 12, it is 2. And of course, groups can be also filtered, okay? So that's the having clause. So here, see what is happening is that please group on this, fine, the same thing, but I only want to match when the department is greater than, when the department is less than equal to 18. I only want to match it for the things that the department is less than 18. So this group, I'm very sorry. So this group that is that has this ID 18 is not important any further. I do not want it. So I only want things that are less than. So LT is less than 18, and this is what is being done. Okay. So so if there are questions, please do ask. Otherwise, okay. So there's a question. So does that mean we can't use the select function on this? No, you cannot use the select function on this. Please remember that this is not the SQL system. So the SQL syntax does not work. So MongoDB is a NoSQL system. It is a system, completely different system by itself. So none of the SQL syntax will work. There is SQL-like syntax, and I will send in the slides. I mean, I'll upload this tutorial for MongoDB and the comparison chart between SQL and MongoDB. But please remember that none of the SQL syntax works. Okay, so you cannot say select from, where, group by, having. However, there are ways of doing it, as I'm saying. So aggregate is essentially group by, right? Then that filter is essentially the where. And this db.student, by saying db.student, you are essentially saying from student. Okay. So does that answer your question? Okay, great. So let me move on to this. So can you see the screen? Can you see the terminal? Great. Okay. So then let me see. So here is the way to start Mongo, because I already installed, and I'll send you details of how to install MongoDB and etc. Once I install Mongo, I get this terminal. Okay. So it's just like that SQLite terminal. So first thing I can do is show DBs. So I'm saying, okay, please show me all the databases, right? And so I had been practicing with this academic database, and by default, MongoDB has this admin, config, and local things. Okay? That's okay. So I don't need to do this. So let's say let's create a database. Say use practice. Correct. That means I'm saying please use this practice database. Now, if you see, this database has been automatically created. Okay. So now, okay, if I say DB, yeah, so that means which database I'm working on, I'm using this database practice. Okay. Now let's say we do that first command, right? So db dot department. Oh, okay, just the slides, right? So let me do that. Let me start sharing the screen. Can you now see the terminal? Okay, great. So now I am using this database called practice. I've just created it. So now I'm saying db.department.insert1, right? Remember, this was the syntax that we were using. So this is the thing, right? So it gives you saying, right? Now, if I want to see what are the collections in this database, so I may need to find out what the collections are, right, in a database. So I can see. Okay, sorry. So there's a mistype. So this means that in this database, there is one collection which is department. Okay. Now let's see what are the things in the department. If I just do this, then it shows that there is one object which is this thing. And remember, this is why we had inserted this. Department 12 named this thing, correct? Now let's insert a little bit more. So instead of insert many, instead of insert one, let's say insert many, and this is what we need to do. Just 1 second. Great. So now you can see that there are 3 objects here, right? So please, I mean, I can see the chat box. So if there is any question, please do type it in. I can try to try to do that as well. Okay. Okay, great. So now the thing is, once you exit from this, don't worry, MongoDB will save all your work. So I have exited. Fine. Now let's see. Let me again go to Mongo. Okay. And let's say I use, so now if you see which are the DBs present, there is a practice DB present. And now let us say use practice, and let us say db.department.find. So it is all there. So it's nothing to be worried about. So the durability is maintained. So once you have done some changes to the database, it is permanent. Okay, great. Now let's say that, okay, let's say that I have a database, I have this file called students, right? So I have this 5 students and this roll number, name, department. I have given this thing. So now let's say I want to import this directly into this database without typing them one by one, right? So there is a command called mongo import. So Mongo import, then I'm saying, look, I am inserting data of type CSV because this is comma separated files. I'm using the database. So -d is for using the database practice. Then the collection that I want to create, the name of the collection is student. Then I want to say that in that file that I'll be using, there is a header line. So the first line is a header. So that's not real data, but that tells you what the fields are, right? So I want to say that there is a header line, and I mean, then I can just say the name of this file, right? Students header.cs. Good. So now it says connected to localhost, imported 5 documents. So let's see whether it has imported or not. So you see, and now you can see that. Right. So it seems to have now created 2 things. The department was already what we created by hand, and student data is what we have imported. Student, so let's see what is there in the student thing. And you can match this. So this role is 11239. So it is in some order it has done it. 11239, and this name and this department is 12 and so on and so forth, right? So now it has inserted all this data. Great. And now I can also start using things like find. I want to use some particular this thing. So it only returns that roll number, which is 11239. Correct. Then I can also say that, look, I do not. I'm not. So when you say this roll colon this thing, that means it's an equality. If you want to say, let's say, less than equal to 11239, right? Now, one important thing to remember is that these brackets should be typed properly, and you can see that there's a small blue thing, so it shows you what it is matched with. So this is matched with this is matched with this is matched with this, so on and so forth, right? So if there's an error, it will of course, it will show you. So now if you do this, I'm saying, okay, find me everything that is less than or equal to 11239, the roll number field, and these 3 things are, returned. Okay, great. So I can also do this with saying, I can also, yeah, so this, I can also say department is 18. So I want to end. So I want both these conditions to hold, or I can say I want a or condition on this. Correct. So I want to say that I want a or condition on this. So what are the or conditions? The first or condition is, okay, so this is the syntax. So so the syntax needs a little practice, but once you are done, once you practice a little bit, it should be okay. So this is or. So I want either the roll number to be less than equal to 11239 or the department. Okay. So I think I have mistyped it. Yeah, sorry. So here, so because this is one or condition, this is ORed with this. Okay. So I want either the roll number to be less than equal to 11239 or the department to be this thing. So for example, if you say this, you can have either greater than this or department this. Okay. Great. So that does this roll number thing. And okay, fine. So let me go back. So if in that case, okay, so this outputs all the fields. So if I want only, let's say, the roll number field, I can do this. So it only outputs the roll number field, but as I said, it also does that underscore ID. So if I say, then it's only the roll number field, right? However, I can kind of do the other trick as well, which says I do not want the name field. So then please note this thing. So if I do not want the name field, that means I just put name equal to 0, and it suppresses the output of the name field. It does the output of other fields, but it suppresses the output of the name field. Okay. Just one second. Let me just note it down. Okay. All right. Sorry. Correct. So once this is done, okay. So this is, so there are deletions and all those things. So one can look at this, update and delete. That's not so important. Let me go to the aggregate thing. Okay. So the other thing is db.department count. You can do this. This is because there are 3 things in the thing, and you can also say sort. Okay, so the sort, sorry, this is aggregate. No. AM. Oh, okay, okay, okay. I'm missing this. Okay, okay, hold on. Yeah, so it has to be in the correct order. So, so this is just sorting. So I'm sorry for all these other attempts. It has to be in the correct order. So it just have to remember these things. Okay. What else? So we can try this group by kind of thing, right? Grouping on these things. Okay. So what was the group command? Just a dp. Okay. And the group command was so this group set, right? So this you can also say, and then it will fall. So you have to have a aggregate field which is underscore ID. So you have to say the underscore ID is what you group on, and then what do you want to group. So you can group, you can roll the, you can sum the roll, or you can just sum one. That will just give you the counts and all those things, right? And as I said, you can also match certain things and then do this. So this can be also done, or you can say this can be also done. So you can first match all these roles that are, I mean, you can first find all the roll numbers that is greater than 11239, then you group. Or what you can do is, you can match. So if this is done, let's try to see what will happen. So your first grouping and then matching, then what should happen is that nothing, because the group is not on this department, the group is on department while the match is not on this thing, right? So it will just return you an empty set because it's just not doing anything. Okay. All right. Okay, so anything else you want to, I mean, I need to show you some practice. So there's a, I'll send you this, what do you say? I can send you the slide, I mean, I will actually post online the MongoDB um, um, the tutorial slides, but anything else other than that you can try. Yeah, I will definitely do that. Okay, so otherwise, are there any more questions? Is there anything else that you want me to try here on MongoDB just to show the things that we need? Just be remembering that. So what I was struggling is to remembering the correct order of this brackets, which is first and which is second. But with a little bit more practice, I think we can all get it. So, okay. So anything more that we need to do? No, great. So this ends the course. So if there are any questions on any other parts of the database course also, that also I can try to answer right now. Not just today's session, but in any of the 5 sessions. Well, if there are none, I hope these sessions, etc., helped. And I will post the slides. I will post the documents, these things, and I'll also post the quiz as soon as possible. All right. So great then. So let me then stop. Okay. Thank you all. Thank you.